Hello student, today we will discuss potentiometer and where the potentiometer is used. Very long wire, near about 10 wires we use in potentiometer. Like this. One rheostat, this is the experimental setup in which battery, key, ammeter, rheostat, galvanometer, this is source battery, and these are the two cells. Now this is another diagram, shows the principle of the galvanometer, principle of the meter bridge. Potentiometer, it is basically a long piece of uniform wire, sometimes a few meters in length, across which a standard cell is connected. The wire is sometimes cut in several pieces and placed side by side and connected across the end by thick metal strip. 10 wires. Sometimes 10 wires are used. Now the principle, a constant current I flows through wire. Since the wire is uniform, the potential difference between A and at any point at distance L from A is directly proportional to L. V is directly proportional to L. A is what? This point is A point. This point is A point. Now when we say the potential drop between A and at any point L distance from A is this. It is directly proportional to L. V is directly proportional to L. To remove this proportionality sign, one constant K, V equal to KL. K is called potential drop per unit length, or K is called potential gradient. In meter bridge, in potentiometer, current is always constant. Here AB wire of potentiometer is shown. This AB may be of 10 meter, 10 meter, 5 meter. You can make 5 meter. So you will not require to move a long wire of 5 meter. You take a meter scale of 1 meter, then cut the wire, use one strip there, then come back like this. Suppose 5 meter. So 100, then strip, then 200, then strip, 300, strip, 400, strip, 500. So this point is B, this point is A. Now, if the potential at point A is 10, so the potential at point B will be 0. Whenever the positive terminal of battery is connected, so here it will be 10 and 0. The potential difference will be 10 minus 0. Now see what is the meaning of this. If we have potentiometer connected with a battery of 10 volt source battery, so this will be 10, this will be 10, this will be 0, this will be 5. So what is the potential difference between these 2 points? 10 minus 5. Between these 2 points, 10 minus 0. Between 10 and 6, 10 minus 6, 4 volt. Potential drop AP, it is directly proportional to length. More the length, more will be the potential drop. V by L, it is called potential drop and it is called potential gradient. Now we will use potentiometer to compare the EMF of two cells. Circuit diagram is here. Close key and allow suitable constant current with the help of rheostat. Insert the plug key in the gap between terminals 1 and 3 of two-way key so that cell of EMF E1 is in the circuit. This is typical diagram of cell. Here we have source battery. This is E1, E2, emitter, rheostat, and we have to compare the EMF of E1 and E2. When we close 1 and 3, this circuit will come in the circuit. And now 1 and 3 is connected. This is J. This is J, jockey. So when 1 and 3 is connected, galvanometer and jockey is here. So we have to search one such point at which galvanometer will give the zero deflection. If you touch, as soon as you touch 1 and 3, when 1 and 3 is connected, cell E1 in the circuit. Now if jockey J is connected here, so galvanometer will give the deflection left hand side. And if J is touched here, galvanometer will give the deflection on right hand side. We have to find, adjust the position of jockey on potentiometer wire where if pressed the galvanometer shows zero deflection. Let it be when jockey is at J1. What is J1? J1 is that point at which galvanometer shows zero deflection. See, these are the two cells and this is two-way key. And this is galvanometer. So when jockey is touched at point A, galvanometer will give the deflection on left hand side. When jockey is touched here, this is A actually, and this is B. So when jockey is touched at near A, galvanometer shows the deflection in left hand side, and when it is here, galvanometer shows the deflection at right side. We have to press and search one such position at which galvanometer shows zero deflection. Adjust the position of jockey on the potentiometer wire where, if pressed, the galvanometer shows zero deflection. Let it be when jockey at J1. Actually this is. So at J1, jockey is touched and galvanometer shows zero deflection. Now when it shows the zero deflection, so AEJ1, this is AEJ1, this and this wire are in parallel. So note that length AJ1, say L1 of the wire, as there is no current in AE1J, the potential of positive terminal of cell is equal to potential of point A, and the potential of negative terminal of B of cell will be equal to the potential of point L1. So E1 equal to V AJ1. So E1 equal to remove directly proportional KL1. So for first cell we get null point, say at distance L1. So E1 equal to KL1. Now repeat join 2 and 3. In this, when 1 and 3 is connected, jockey is touched here, galvanometer shows zero deflection, we get one length. Similarly, now join 2 and 3, we get another balancing length, that is L2. So corresponding to cell 1 and 2, we get two balancing length. E1 equal to KL1, E2 equal to KL2. Divide E1 by E2 equal to KL1 upon KL2. L1 KK cut. This is, by calculating the length, we can compare the EMF of two cells. Okay. It's all these two questions, one based on meter bridge and one based on resistance. Thank you.